So we went through some basic introduction to the normal curve. Now we're going to look at some of the problems. Okay? We ended with showing the 6895.9.7 rule. These percentages are important. You should get to know them and feel comfortable with being able to label those percentages in. As long as you can remember these numbers, you should be able to figure out what's going to fall in here. Okay? If you remember 34 and 34, 68%, then you should be able to figure out, okay, 95%. What else do I need in those two sections to give me the 95%? Now the problems that you're going to see. Set up the normal curve for a mean of 80 and a standard deviation 80. This is a very generic example here. It's telling you what the average is, it's telling you what the standard deviation is. And the average is always going to go in the center. Now with that 6895.9.7 rule, we need 3 dashes to the left, 3 to the right. And this is it's supposed to be symmetric, so as best as you can, this is showing you where the standard deviations fall. Again, it's supposed to be symmetric. If mine's not perfectly symmetric, please forgive me on that one. And this is where our standard deviations are going to go. You're not going 81, 82, 83. You're counting by standard deviations. So you're going to add those standard deviations to the 80. So if we start at 80, 80 plus 8 is 88. 96, 104. That's just plus 8 plus 8 plus 8 going across. Going the other way, we subtract. 72, 64, and 56. Minus 8, minus 8, minus 8. Let me just do my math again real quick. Okay, we look good there. Now, the percentages that we had before are going to stay there. 34, 34, 13.5, 2.35, and 0.15. Right? So those percentages are on stay, they're the same. Okay, but now you know we have different values underneath. Now the questions that you're going to see are things like this. What is the chance you get between 64 and 88? So if we randomly select someone from our population, what's the chance that they fall between 64 and 88? And it's going to depend on what you're talking about. The way you should look at this is find your 64, find your 88. And we're looking in between those two sections. These values represent the line, not the section, but it represents the line separating those two sections. So all the sections in between these, 1, 2, 3, we're not add up those percentages. 13.5, 34, 34, and if you add those up, you should get 81.5%. Falling into one of those three sections would be about 81.5%. Right? More than 72. It's not being important you understand the language of at least, more than, greater than, no more than. Those are all terms that you're going to hear a lot in this section. So what's the chance of getting more than 72? Here's our 72. More than is going to be to the right. So you're adding up every section from that blue line over to the right. 34 plus 34, 13.5, 2.35, 0.15. Okay, and if you add all those up, that should give you 84%. So once you have the curve set up, really it's just being able to add the percentages together. Okay, so let's erase these. Okay. Erase this here. We have, okay, the average grade in Mr. Booth's senior math class is a 67 with a standard deviation of 2%. So here's a situation now where I'm telling you the average is 67%, standard deviation is 2%. So that's the sample that we're taking, and that's what we're on base our normal curve off of. We know the center is 67. We have our 3 dashed lines going left and going right. Add by 2. Okay, standard deviation is 2%. We're not count by 2%. 69, 71, 73. Going the other way, subtract. 65, 63, 61. And the percentages again are going to be the same. So if you need to fill them in quickly, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. Same basic questions. What's the chance of getting at least a 69 in Mr. Booth's class? Now this again, you have to remember these are randomly pulling people. Okay, the random part is important. I know it probably shouldn't even be in the question, but these are randomly pulling a student. What's the chance they're getting a 69%? And it says at least. At least means 69 or higher. So there's the 69 line, and that's on the everything to the right. So that means those three sections, 13.5, 2.35, 0.15, adding all those up is 16%. What's the chance of getting between 61 and 67? Here's the 61. 67 is the center line. So I'm adding those three sections up. 2.35, 13.5, and 34%. And they should add up to 49.85%. 49.85%. Okay? So yeah, once you have it set up, it's just adding. As long as you find the correct areas, as long as you're picturing and using the correct areas, you should just be able to add up those sections. Now, unfortunately, we only had those 7 values underneath. There's on the other techniques of using normal curve to find probability. If you take probability statistics or AP statistics, that will get a little more detailed and give you more freedom of what questions you can look for. Okay? Z-score is going to be the next thing we look at. Now, we're going to look at the very basic interpretation of Z-score. We're just going to use it to determine if a number is normal or not. Okay? Now, the formula for Z-score, I have it as x minus x bar divided by standard deviation. X, the score in question, minus the average divided by standard deviation. Now, these symbols are for the sample that we took. If you look this up, you may also see as x minus mu divided by sigma. These symbols are for the population. So depending if you're talking about a population or a sample, is on determine what formula you're looking at. Okay? I know with the calculator we find x bar and s, so that's why I wanted to use this formula. Now, how do we determine if something's normal or not? You plug it in this formula, and this formula is going to tell us how many standard deviations away from the average it is. Okay? So, standard deviation is measuring how far you are from the average, that center point. The farther you are away, the more likely we're going to consider you an outlier or a strange score. And our rule is going to be between -2 and 2 is considered normal. Okay? So if you have anything between -2 and 2, you're going to be considered normal. So let's do a couple examples real quick. Okay. Going back to Mr. Booth's senior class, 67 average with a standard deviation of 2. Okay. Find the z-score and tell if getting a 72 is normal. So the 72 is our x. That's the score in question. 72 minus 67 divided by 2. And that's our formula. Put it up here again for you. X is the score in question minus the average divided by standard deviation. Now, I will say, if you are plugging this all in at one time, make sure you put that top part in parentheses. Okay, just order of operations, make sure you do that first. And if you plug this in, the z-score would be 2.5, meaning you are 2.5 standard deviations above the average. So in this case, 72 is outside our normal range, -2 and 2. So no, it's not normal. But for this situation, it's not normal in a good way. You're above the average by 2.5 standard deviations. So you're actually not normal in a good way since we're talking about grades. You want to be higher in this situation. Find the z-score and tell if getting a 68.4% is normal. So 68.4 is going to be our average this time. 68.4 minus 67 divided by 2. The average of standard deviation is not changing. Just the score we're looking at, the score in question. This one should be 0.7. So this one's a lot closer. It's within 1 standard deviation. Okay, so this is close to the average. So yes, it's considered normal. But unfortunately, since the average is a 67, you don't want to be considered too normal, be that close to the average. But for our rule, between -2 and 2, this falls inside, so it is considered normal. Okay? So they're the types of questions you're going to see for the normal curve. Okay? Know the basics, introduction information for the normal curve, also know how to answer the questions.